All right, the section 1.7 is called Postulates for Euclidean Geometry. This is what we're going to call, this is what the geometry that we're going to work with this year is going to be called Euclidean Geometry. We're not going to worry about that name very often. It matches very much with the idea of synthetic and plane coordinate that we talked about before. You don't need to write your objectives down, just the title. We're going to identify and use what we call the point line plane postulate. We're going to go over that, and we're going to review the 4 types of geometries that we've already talked about. So again, the 1.7 postulates for Euclidean geometry, named after a guy named Euclid. So we're going to go ahead and go on. A postulate is an assumption, and it may or may not be true in all geometries. A postulate is simply something that we are going to assume to be true. And sometimes that gets you in trouble, but we're going to make these are going to be assumptions. Euclidean geometry is what we're going to be working with, and again, it fits synthetic and plane coordinate geometry. It fits that idea. What is, yeah. So you need to write down what a postulate is and what and Euclidean. Now you don't have to write the whole thing with Euclidean geometry. This part is the most important part for it. All right, are we ready? Okay, we're going to go ahead. Now, this is called the point line plane postulate. It is, remember, the point line and plane are 3 undefined terms. It's going to give us some assumptions to go with. You do not have to write down everything up here. You have to kind of make it make sense. The first is unique line assumption that through 2 points, any 2 points is exactly 1 line. The number line assumption is every line could be a number line. Every line can become a number line. That gives us that idea of dense, that lines are going to be dense, which means, again, between any 2 points, there's always another point. And the dimension assumption is kind of weird, but if given a line on a plane, there's at least 1 point that is not on the line. So if I can kind of draw that out here, there's our plane, there's our line, and there's another point. So in other words, a plane has more dimensions than the line does. And space has more dimensions than a plane does. We are getting there. The line intersection theorem, two different lines, if they're different lines, will intersect in at most one point. So if I've got two lines that are not the same line, they can only intersect at one point. They don't have to intersect, of course, because if they don't intersect, remember, what do we call them if they don't intersect? What do we call lines like that? It's the second term here. Parallel. Now, some geometry symbols that we're going to go through. So one is, let's go to color. These are a few symbols that we've already gone over, so not a lot of hard note taking now. Just if I write AB like that, remember that means that's the distance. That's the distance from A to B, if I don't put anything above it. If I write it like this, then what does that mean? If I put that symbol above it, what does it mean? You want to take a guess? That's the line AB. That's the line that passes through point A and point B. Now that symbol, that's not written out very well, but this is saying that line L is parallel to line T. Sometimes we name lines with lowercase letters like that if we don't want to identify particular points. So that means it's parallel to, and you have the double lines like that. Let's see, let's do one more. Let's do the segment and then we'll be done. If I have AB with a line above it but without the arrows on it, that's the segment, which we'll talk more about later. From A to B. What's the difference between the line and the line segment? How far does the line segment go? From point to point. A line goes on forever, so that's why the arrows.